This episode of Hak5 is brought to you by Domain.com.
Hello, welcome to Hak5. My name is Darren Kitchen. It's your weekly dose of technoless. We've got a fantastic show for you guys this week, and I'm just chilling.
What are you doing?
I just feel like chilling. Why don't you take care of the rest of the episode?
What are you doing with my beer?
What?
Honestly,
wanted that beer.
You steal my beer too?
I wanted come
Come
on.
here. Come here. You have to come on set. I'm sorry that we've been drinking all day, but listen, we have a show to do.
All right.
My name is Shannon Morse. I'm his co-host.
She is.
We do a show on the internet about hacking and stuff.
Don't blame me. It just happened. What are you hacking today?
Oh my god, I'm gonna break your other pinky.
Hey.
What did you do? Was it just so that you can do the...
Yes, it's so that I can live long and prosper. I couldn't really make it out, so I had to,
What did you do?
I broke my own bone. And that is a reference to season 1, if you've been following along for 8.5 years. Yeah.
Of course you did.
Yes, I did some, well, it was kind of like a Dr. Evil accident. I really want to get into it.
Oh man, I'm sorry to hear that.
Pretty epic. Totally not embarrassing, like, anything.
No girls beating you up?
No, it wasn't like Evil Server and I knife fights in the back of the parking lot.
Oh Lord.
Not at all.
So, I have an interesting segment for you today.
Yes, we are both, it turns out, and...
You do too.
We do, actually. Well, I mean, aside from because we're in the middle of a drone series as well, but we're also doing some SDR stuff, and I didn't even realize this until you came in to record today, that we've both been looking at very similar software-defined radio kind of hacking stuff, a little sniffy.
Yeah.
I've been working on some GSM stuff, we can talk about it next week, which is, as we know, what you use with your cell phone to make calls, right?
That you were doing with
with the Hak5, right?
Yay.
But before we get into that, you're looking at, again, radio-based,
yes,
just like GSM is on your cell phone.
Yes.
A system that allows, similar to, this, which is based on, say, time division multiplexing or whatever have you. You're looking at a different kind of technology for multiplexing, or the idea of allowing multiple people to use the same resource.
So, exactly. Have you heard of trunking?
I've heard of trunking from back in my phone freaking days in the 90s, but yeah.
So, what was trunking back in the 90s?
Well, I mean, it's the same thing that it is today. It's just like you have an allocated set of, say, channels, right?
Yes.
And then what you'll have is you'll have a master channel that will kind of be like the railroad conductor and be like, you guys want to talk? You're on this channel. And then like, oh, here's some other people, you guys can use this channel. It's just managing resources, right?
Exactly.
So, in fact, on phone systems, say you've got a PBX, right, an exchange, right? And you only actually have, say maybe you've got like 30 people in the office. What are the chances that all 30 people are going to be on the phone at the same time?
Not likely.
Pretty slim. So you might be able to get away with just like 8 channels, right? Yeah.
That makes sense.
And then there's T1s, but in Europe they're E1s, and then fun things happen with numbers.
All these things before I was old enough to understand them. But you were, because you're old.
I was old enough. I'm not that much older than you anyway, and I was just like way too into it for
I was still into My Little Ponies. I didn't care at the time.
I was riding my bicycle around the neighborhood finding bellmen that would give me manuals.
That's awesome.
Yeah.
So what I'm checking out this week is trunking for systems like what the firehouse will use or what the police station will use. And there's several other companies in our area specifically that use this same trunking technique for all these different frequencies.
Right, I mean commercial-wise, you can just go and say pick up a Uniden or a Motorola set off the shelf and set up your own trunk system if you're like doing dispatch and you've got like a, I don't know, taxi cab company or delivery company or things of that nature. And we happen to be in a kind of an industrial area.
We are.
Where we have some neighbors.
Luckily. So our neighbor just happens to be there's an oil refinery, maybe?
Yay,
perhaps?
Oil! We love
Which
oil.
makes it smell sometimes, but it's like right next door. So since it's in such close proximity to us, we're able to gain access to all that public information that they're just using on certain frequencies. The trunking.
Oh, fantastic. So how is this, say, different than what you've been typically doing with your software-defined radio, where you fire open like something like SDR sharp and you tune to a frequency and you say, listen to it, whether it's frequency modulated or amplitude modulated?
Yeah, so typically we have SDR sharp. It just does exactly what you said. But in this case, you have to download a completely different program because the data that's going through there, sometimes they have encrypted voice data, and sometimes they just have other kind of data that you can print out.
But you're not just like tuning to one frequency.
No, it's like bringing in a whole bunch of different frequencies into two. Yeah.
Why are you double fisting?
So I have. So let me open up the program.
This one's not even hooked up. We're using the giant one.
The big one sitting next to the window in the other room. Yes. So it was able to pick up a lot more data going through it. So we have one which is the signal, and that's my first one. And then we have a second one, this little guy, which is for the voice.
Oh, we should swap those.
Well, if we did, then this one wouldn't be able to transfer all that data.
So what you're saying is we need two big antennas.
We need two big antennas.
Maybe we'll come back to this. Or we could just drive down to the refinery. I mean, we've got credentials, right?
Just park outside.
Totally.
Yeah, there's a parking lot over there. We'd be okay. All right, so this program is called Unitrunker, and you can find it over at unitrunker.com. Not a lot of information about it on the website. They link to a user guide, but it's not very good for our specific needs. What we're using is their brand new update, which came out in, April 30th, which is for the RTL-2832U, which is the ones that we are using.
I know the RTL. This guy.
So you just download that.
So you're saying with $20 I can start sniffing police radio signals?
Yeah, pretty much.
Oh, I guess it would have to be $40 because you need
$40, yeah.
Yeah.
Less than $40.
The idea. There you go.
So we have this program downloaded, and then what we can do is, the first thing you want to do is make sure that you have your two antennas and that they're both working. So if you go back to our very first segment on SDR and the RTL dongles, you'll find the Zodig walkthrough as well as SDR sharp walkthrough. So you just want to go there and make sure that everything is working correctly for the two hardware devices. Once you have that up and running, you can open Unitrunker. So this is what Unitrunker looks like. It's kind of boring, to be honest.
Oh, come on. It looks like QT, and I love QT.
Yay. It's not that pretty.
Meh.
So you'll see down here that I have two different RTL dongles set up. So if you want to add one, you click Add New Receiver, and then you choose your signal, which is going to be the first one. This is where the signal is going to run into your computer, and then the control. And the control can be your voice. So luckily, they created a new one right here. So this is for the RTL. It's a very special button just for the RTL.
Yay.
So previously, what you would do with the older antennas is you would signal and control. Now you just click RTL twice.
Cool.
So I've already done that. So I have my 1 and number 2. So if I double click on this, you get this nice big window of all sorts of information. Starting from the very top, this is where you put in the type, and once you plug in your RTL dongle, it should automatically know exactly what data and what presets it's going to set everything to. But if not, I'll run you through it real quick. So you have your type RTL dongle. Model is the R820T. This should automatically set for you. Roll. So the first roll that you're going to have is your signal. And then you want to make sure that it is running at the very end of this.
So what is the signal roll?
The signal roll is the one that's going to be bringing in all that data down to your computer to be able to decode it.
So it's the traffic cop that's saying, like, hey, this guy's talking on this frequency and that guy's talking on that frequency, so you can hop around?
Exactly.
Okay.
So
we're using two because one needs to be dedicated to listening to that control channel.
Yeah, one has to listen to everything, and then the other is going to be able to decode that information.
So the other one will bounce around to the different frequencies, actually getting that data.
There you go, yeah.
Nice.
You explain it so well. So first off, we have RTL device. So you'll see I have two different RTL devices here. So my first one is going to be this crazy number. And then we want to change the correction. So you remember from SDR sharp when we had the PPM correction?
Oh yeah, we did that with AIS. We had to I forget what our offset was, but you know, every dongle is going to have a different offset.
Right, so mine has a pretty big offset of 50, so I just changed it to 50. There you go. Also, I set mine to auto gain. And then down here, you want to turn off squelch if squelch is on. And you also want to make sure that both of these are checked, mute and de-emphasis. And down here, audio output. So remember VB virtual cable?
Yeah.
Yeah, so we downloaded that previously to use with, I think, the airplane tracking. This time we're using it for the trunking signals, so we're going to make sure that we change the output to the virtual cable. Now, park. So park is the actual signal, the main waterfall that you want to listen to.
Okay.
Now, the way that I figured out which one matches our corresponding company that we're going to be listening to is from this website.
I was about to ask, how do we even know what signals to go through?
Exactly.
Or
We know
how
that
would we even know what they look like if we're just looking
we
at a
know that
waterfall?
most of these trunking signals are going to be between like 800 and 950
Cool.
megahertz. But we don't know exactly where to go unless you just sit there and listen to them all freaking day and you find one. Well, luckily there is a website that already tells you exactly where to go. It's called radioreference.com.
Oh, yay for public info.
Yay!
So what did you find here?
So you just go to radioreference.com, and if I go to the main website, you go to reference database, and from here it's going to give you a map. So you choose your state, and then you choose whatever county you're in. So we're up in San Francisco, Contra Costa County. And then from here you just scroll down and you can look at all the different trunking signals that are available in your area. Now if I scroll all the way to the bottom, it'll show me all trunked radio systems in Contra Costa County.
Fantastic. Oh, AT&T's got one.
Yeah,
oh,
AT&T.
Bay Area Rapid Transit.
BART,
BART
yes.
system. That's our subway.
East Bay Regional Communication System. There's a PG&E one, which is our local.
Oh, let's not blow that right. Yeah, we're going to be having smart meters. So.
Our electric peoples.
Oh, cool.
Yeah, there's Golden Gate Bridge Highway and Transportation District. There's the police. Like everything is a trunking system.
Sweet.
So now a big difference about these are, and I'll open up a couple of different ones for you. Now let's take a look at BART. So notice how BART is analog.
Yay.
Pretty cool, right? And then we go over to here to East Bay. So this one says APCO 25 Common Air Interface Exclusive.
Okay, so that's the protocol it's using.
Yeah, so this is the protocol. Well, some of those are encrypted. Analog is not, but these APCO 25, there's a P25 one.
That's a pretty common one.
Yeah, there's several different ones. We can listen to analog with Unitrunker.
Sure. We may have to do a follow-up to this to get into some of these digital ones. 'Cause
Exactly.
that would still be fun.
There's a bunch more steps involved, and there's another program that we can use to be able to decode all of those encrypted ones. But yeah, that's totally possible.
Okay. So you found an analog one?
I did. So
And
this
it's
one
nearby?
is the Chevron Texaco Richmond Refinery. It's an analog, and then I scroll down and I can see what their control channel is. So this is the channel that's going to be bouncing back and forth between all the different presets that are coming into it.
Cool. So we can listen into all the Chevron worker bees turning the oil into gasoline.
So we have three different ones. The blue ones and the red ones are the ones that you want to listen to.
Okay.
So I was able to get some information from the first one, the 858.337 and then 859.337. So when I go back to Unitrunker, and there we go. I can type it in right here, 859.350. Yay!
Yay. And so when we run both of these, what do we end up with? Like, how do we visualize this? How do we hear this?
So once you get both of those set up, and let me show you voice real quick too. So this one's set to my other RTL dongle. It's set to voice, and then down here, auto gain is checked again. My PPM is 50 for this one as well. Cable output is the audio output.
Ah, okay.
And
So
then
we just
park.
choose like if it's our laptop speakers
Exactly.
or headphones or.
And then park for, on this case, for the voice, you want to set it to 0 because you want it to listen not to a certain channel, but to the other antenna.
Aha.
So
that dongle's listening to that dongle. It's getting its
Yes.
signals of where it's going to tune into. Over
exactly.
there. Cool.
So once you hit play right here, both of them are going to start running, and it'll say running underneath the run status right there. And after about, I'd say 30 seconds or so, you should see this page pop up. So this is where you're going to start seeing all sorts of data coming through. And this will only pop up if you're actually getting any sort of data passing through to your antenna.
And
So
so
if you don't get anything within like a minute, I'd say restart and try to rerun the program and try different channels as well.
Okay. And so what kind of stuff are we seeing here?
So it's kind of weird. I haven't figured it all out yet, but we see actions are the most interesting part. We see call action join action, so people are joining some kind of call, some kind of channel. You also see log-offs, log-outs. I think that's about it down here. Yeah, lots of joins. You see source IDs and stamps, which is the time. No source labels. I would like to see something under source label. I haven't seen much yet. And then up at the top, we see the frequency that we've joined, 858.337. And then sometimes you'll see a target and a source show up here as well.
Oh, so if they're having a conversation.
Exactly.
All right. Well, we're not getting really a lot of traffic right now, and I think it may have to do with this.
It's probably because that one's such a tiny little
So we either
antenna.
get closer to the facility, or we plug in some, oh, I don't have it right here. Oh, we have a
What?
Yagi.
Oh, that's a good idea.
Well, it's tuned to 900 megahertz, but it's close enough that it could probably get us.
You think so?
What did you say? This is in the 850 range?
850s, yeah.
Yeah, it should be
850,
able to do
860.
it. Yeah. Interestingly, we're both having fun in the same range because
Yeah.
that's where I'm having fun with GSM.
I'm curious about, I want to increase this antenna and see if I can get some more voice data, and I also want to find out if this channel specifically is actually, if anybody's actually having a conversation between each other, if there is some voice action going on.
Okay. Or we just strap this to a drone and send it over a refinery.
That's such a bad idea. Or
Well,
maybe
the current
it's a good
FAA
idea.
regulations don't necessarily
God.
prohibit this, but
Of
no,
course.
we're not going to do that.
No, we can't do that.
We're not doing that.
We're not making a
We're
segment
so not
out of
doing that.
We'll get fired.
We'll be at the park.
The dog park.
Yes.
With the fleas. So it's pretty cool, but I really want to
Okay, so
decode.
we need to follow up on this.
Yeah, I want to decode and I want to find some freaking
Well,
conversations.
let's dive into more of the P25 stuff.
Yes.
When we can find some more signals as well as upgrade our antennas and get into some of the digital stuff. But
That's a
hey,
good
that's
idea.
pretty cool so far.
It's pretty cool.
And I guess next week I can show kind of like where I've gotten so far as well
Yay.
with the GSM hacking. But the rest of today's episode actually has to do with drones, although we are not in fact flying over a refinery because that would be bad. Don't do that. Instead, we're actually going to be building, we're going to start assembling, in fact, our
drone?
yes, the open
The
source
drone?
paparazzi drone. Yes.
Yay!
So all that coming up right after this.
I'm so excited.
Doesn't matter if you're into P25 trunking systems or OpenSky or Tetra or Logic Link or, my God, that's the beautiful thing about standards. There's so many to choose from, and when that killer idea hits, you need to snag yourself a domain name and web hosting fast. And get this, with Domain.com's quick domain discovery system and their easy checkout process, you can have your website up and running in no time. I love the guys over at Domain.com. They are affordable, they're reliable, they're easy to use, they're huge on social media. You can tweet them at Domain.com and see why we think they're just a fun place to do business. And get this, the guys over at Domain.com, huge fans of Hak5, so they want to hook you guys up. That's right, use the coupon code HAK5 at checkout and get an extra 15% off. When you think domain names, think Domain.com.
We're back and it is time for the trivia question of the week. First off, last week's trivia question was, what was the first commercial application of microprocessors? And the answer was calculators. Of course, why wouldn't it be a calculator? Ha! Yay! I don't know what that meant. I don't speak German. Was that German? Was it German?
Yeah, du Noob.
Yeah. Oh my God, don't call me a noob. I'm gonna throw this antenna. My antenna, I'm gonna throw it at you. This week's trivia question is, Ethernet superseded which network technology? And you can answer that question over at hak5.org/trivia for your chance to win some awesome Hak5 swag, like Darren's t-shirt. One ring to bind them.
Hello and welcome back to our drone building segment here on Hak5. Peter's with us and we are going to finally get into the nuts and bolts of it literally as we put together our airframe.
Let's get building.
We absolutely should. We made things super easy for ourselves because rather than go and spec out the right balance, because it really is a balance of frame and motor and ESC and propellers. We already, well, we know we have in mind the paparazzi because of the autonomy and because of the sensor stuff we're going to be doing later. We've made it really easy for us using a kit frame, and this is so great because it allows us to get started much quicker, get it up in the air, and then later on, if we decide based on the way it flies, we can kind of get a sense of what it is that we'd like to customize later.
Yeah,
and this is a really great frame.
Yeah, this is a kit that you can purchase, and it's so-called Bumblebee.
It's got like even little yellow stickers and stuff to make it all cute. In fact, the canopy has a lot of character, I would say. Oh,
yeah.
Look at that guy. What's really great about this, though, is this is a hard shell cover.
Hard shell, and it protects your electronics and your payload.
And there's a lot of room in here. This is the main piece of the frame, and so this will go over this.
Yeah.
And there's a ton of room in there for, I mean, I could even put a pineapple on this, no problem.
You probably wouldn't want to like start flying for the first time with this kind of a set, but it is perfect for our project.
In fact, actually, when you get to that, I should probably say that when I'm flying, when I'm starting out, and when people ask me like what they should get and whatnot, I always recommend something like this. This is, you know, find yourself a little toy quadcopter and fly around indoors, because even though it may not be like a full-on RC controller, the same exact physics apply. In mode 2, you've got you know,
it's
your throttle,
hand-eye coordination, basically.
Your roll and pitch, everything is exactly the same. So if you get comfortable with it flying indoors, especially very safe place to fly these little mini toy copters.
Yeah, what is basically important about this is that when you learn to fly, you want to, even if your actual goal is to fly completely autonomously, you have to be able to take over.
Oh, yeah.
And save your
We
system.
say autonomously, but that's with with line of sight, and watching it and having your finger on the fail-safe switch, so that at any given moment you can switch
take
back
over
into manual control.
Yeah. That's so that you have always the control. It's like as we were talking in one of the earlier episodes, the AMA rules. It is line of sight, and you have to have actual RC control of the vehicle itself, and it makes total sense. It's like when the software fails, it's like we have to be able to fall back to human control.
And so learn on a toy. And the other nice thing about learning on a toy, as it completely translates over to the bigger ones, and so you'll feel more confident with those, is that, you know, maybe, you know, you'll find out if it's for you, right? Because if you're really enjoying a $40 toy, then this is going to be only that much better.
Yeah, that much more.
And this is actually not expensive at all.
No, so it is not very expensive, and why we chose this airframe, besides the ease of assembly and so on and so forth, is basically the space. It's like we want to have the space to do the wiring.
It's kind of a Cadillac of quads.
yeah. It's you can run new wires in it. You can tune. You can change. It's like it's very nice and flexible. So it will grow with you as you progress and have new expectations and new needs. So it is a very good compromise between price, complexity, and
what's also really nice is since we're doing all of this tuning here and all of the setup with the paparazzi, what that means is anybody else, you know, you can just go ahead and pick up the same airframe and know that it's just going to be in the drop-down menu.
It's one of the default airframes. Yes, we showed you the other day how the ground station looks like when you are selecting the airframes, and we will add that as an example airframe to the whole setup. It's open source, no problem. We pull request and stuff done.
All right, so let's get into it now. There is literally only one change to this airframe that we have made, and that is on this main section here where the booms come out and our motors are hooked on. We have the top section here and this top plate, and this is all carbon fiber and some bits of plastic, mind you. So it's really robust. All we've had to do is drill some holes so that our flight controller is going to go ahead and fit nicely on there in that way.
Yeah, so that the holes are aligned. We can screw it down nice and tidy, and everything is
you don't want your flight controller moving around outside of the airframe. This isn't something you just kind of zip tie on or something.
Yeah, you want to have your co-pilot nicely strapped in.
yes, exactly. All right, so the assembly is really straightforward. This is like Lego. It's pretty obvious. There's no, you couldn't, for instance, put an AGP card in a PCI slot. It just won't fit, and these are the same way. So what you get with this is we've got our motors. These are brushless outrunner motors, and these are the specs are that they're 930 kV. I don't think we touched on that before.
Yeah, so this means that this motor will rotate with 930 RPM, rotations per minute, when you apply 1 volt to the motor. So per volt applied, this is the RPM.
So if we gave it 1,000 volts, we would have 909 million RPMs, right?
Yeah, and smoked motor probably.
Yeah.
But yes, that's exactly how it works.
And the other really nice thing about this kit, again, is this is actually the pod that the motor attaches to, and built into this, there's a nice little space for it and everything. You can kind of see down there that PC board, that red PC board. That is, in fact, the electronic speed controller, and it's covered in this nice little housing for your first crash.
It's protected,
Yeah, it's
but
protected,
also
nice.
it allows the airflow to cool it while you're flying. It's still a high power electronic device, so it needs to be cooled.
Right, there are actually a couple of schools of thought when it comes to electronic speed controllers and where they should be mounted.
Yes.
You know, some could make a very good argument that they should be mounted more centrally towards the inside of the vehicle. The benefit of having them out here is that they are cooled better, and then they're away from our other sensitive electronics and other sensors that they could, I guess, one could say that could potentially cause.
Well, they could
interference with.
interfere. It's like there's a lot of schools. The disadvantages, though, that you have the DC wires going longer, and there is also a rule how much capacitance one should apply. But this is already chosen for us, so we don't have to get into these details for now.
No math for us. Yes, that's fantastic. So we've actually already gone ahead and prepped the turkey, if you will, and we have 3 of these booms already done. But let's just go ahead and walk you through
one of them.
If you want to take over, and I'll grab this guy.
Yeah, and I will
grab the hex.
Let's move that away.
Screws.
And so the first thing would be to remove the
housing.
The housing, and there are just 3 little screws. And the easiest is actually to flip it open, and then we have to take off the wire so that it is not strapped together. And so what we are doing is rerouting the wiring so that it is easier for us to modify and change things.
Right. These are carbon fiber spars, and the way that this is made to be set up is that you would actually run your wiring through that carbon fiber spar, which is going to look really good. You won't have any exposed wires, so it looks great. However, it's going to limit our ability as far as like routing our cabling. And also, given that this is our quote-unquote first build, right, as an entry-level quadcopter, we really want to be able to get access to those more easily if down the line we have to, make changes or fixes or, as we grow with the quadcopter. This being first.
you can decide to just leave it in the booms. It's like another advantage of having them routed outside is there is plenty of space, but it's still a squirrel cage that you have to pry the wires out from. So having them on the outside will make the wiring much easier.
Yes. We can make it pretty later if we really want.
Yes.
All right, and then we go ahead and mount our motor.
So when you look at the motor, the holes are not symmetric. So there are 2 ways of mounting the motor onto the pod. If you look at it here, so the pod also has the holes here.
And it is also not symmetric, so there's only 2 ways you can do this.
So there are 2 ways. One way would be this way, but this is the wires are like coming out on the side. We decided to mount it the other way. Then it bends over and it is easy to plug in.
Do you want to pull these out a little bit so we can get those plugged in? And so you'll notice that these 2mm bullet connectors that we're plugging in, this is going from the motor to the electronic speed controller. And while there is on the motor side a black and a red and a blue, all of our receiving cables are blue, and this is because For right now, it is not going to, in fact, matter how we plug them in. Later, when we decide if they're going to be clockwise or counterclockwise, we'll go ahead and swap those, and we'll show you it's pretty easy.
So the order that you plug them in decides the rotation direction of the motor. So when so it will turn right or left. We touched on that before.
And we don't know which way it's going to be right now. It's really a trial and error thing.
Yeah, you have to.
Can't hurt anything as long as you don't plug in some props.
Yeah, just leave the props off and try it out. But we will get to that.
Okay. So mounting the boom is pretty straightforward.
So there we go. And the boom has a hole in it here that goes all the way through. And we align it with the holes on the pod. And that should be that. Yeah, just hand tight.
There we go.
All right. So we have 4.
All right, and then the next step is going to be to go ahead and connect these booms to our center. And to do that, I'm going to need a couple of hands here. Essentially what we do is, you can see that there's these notches in here, and so there's actually 2 ways that these pods, or these booms, I'm sorry, can go outwards. Obviously in our X configuration, but what's really nice about this frame is that these arms can actually fold in, and so what that means is you'll be able to take this, otherwise large volume quadcopter and fold it all down, that you can like strap it to a backpack, go hiking with. I've done that with this frame.
Yeah.
So it's really great for that. And in order to get everything happy,
like a foldable basket or something, you can put it in probably.
so these just snap in place. You're going to go ahead and snap those in, not in the X configuration.
So in the straight configuration.
Yes.
There you go.
All right. And now we just take these long screws. And so what we end up with are these long screws that are only threaded at the end, as well as some nylon washers, and of course our nuts. And so what that's going to do is these are going to, we're going to sandwich this whole thing with this top plate.
Yeah. We will mount also the screws to mount the autopilot already, so that they...
Right, we should do that first.
Yeah, we should do that.
And then, so this is why it's good to like not screw everything down immediately. You really want to like kind of like play some chess with it and think a couple moves ahead.
Yes.
Because once we've got that mounted, we'll then send this through, and what'll happen is this will go through here, and then through this end here, and then all the way to the bottom where we'll put the nut. And it's tricky because you've got to get the nylon spacers there as well so that it slides real nice. But we do that 4 times, and then that is the most challenging bit. And then it gets really rewarding because then we can like spread the wings as it were.
Yeah, so
Well,
I will get the 2mm screws
Sounds
for
good.
the center plate. So the Lisa M has 2mm holes in it. So we just have the same holes on the center plate here. So that we don't have to do that later, we can just run the screws through the bottom and use nuts as spacers. That's the easiest way of doing everything. Just put one nut over. And we will later have just 2 nuts on top of each other to have enough distance from the board to the Lisa M. And that's just what we have to mount for now, but that's it. All right. There we go.
All right. This is going to be the fun part. So let's kind of move this over because it'll take the both of us to to do this, and we want it to be in that camera. So if I flip this over, you'll see it's going to want to go through this hole. Okay, and these nylon spacers go
between the boom and the plate, right?
You know what? They could.
So that it slides
Yes,
nicely?
they do. They do. So go ahead and thread all 4 of those. So what you'll want to do is go ahead and set your screws in, get those nylon washers on the tops there, because we're going to do the same thing on the undersides of these with the washers, and then we're going to send the whole thing through and then put the nuts in place. So this means now that we need to line these up and put these nylons underneath it.
Underneath it, okay.
Yes. So, for example, so what we'll need to do there is scooch these over so that they're right on top of their receiving holes, and then take that nylon spacer and just set it right over there. And it's going to take some wiggling around to get that perfect.
This one already wants to scoot over.
Okay, hang on. Before you do that, what I've found is it actually helps if you get your pods level. So just take something to kind of lift those guys up so that they're pushing up against those spacers. And same thing over here with my multimeter. There we go.
Now, when we get the washers to be submissive.
Yeah. And this is a difficult thing because gravity is kind of working against you in this sense, but you just line it all up.
Against and for you, just work with the gravity.
Yeah. All right. I'm going to set this down so that I can help. Okay, I'm not coming through on this one. There we go.
There we go. Come on.
Come on, come through.
Come on, you can do it.
Oh, we don't have 3 out of 4? We only have 2 out of 4?
We have 2 out of 4, yeah. We can.
Okay, so
Maybe we want to turn it around.
here, let's just hand tighten those nuts onto the bottommost of these because we don't want to lose the 2 that we have. Just give it the old reach around.
There we go.
Great, let's see what's going on with these puppies.
Yeah, just tilted mostly. See?
Oh, I see. Okay. And so it's literally just a matter of lining these holes up. So if we want to start wiggling.
This one.
Contact.
And then. There we go.
Wunderbar.
Wunderbar. And now we need just the nuts. 2 more nuts.
Which are, well, we're the 2 nuts, but we also have these things to put on the screws.
That's right. Can do it. Great. Now we should tighten
everything
them.
down. Yep.
And turn it around. Oh, wrong size. Yeah. It's like, let's tighten it, untighten it first, then we can take a wrench from this side. So
Here, I'll
one
hold
side
the
and
wrench.
this side. Yeah,
Yep.
have it.
And you're good to go. See, it
Awesome.
really is just like building IKEA with your girlfriend. Except my girlfriend's prettier.
I hope so. Okay, next one. Don't know how tight. Yeah, you have to adjust the tightness here a little bit so that it still moves nicely. Okay, next one.
All right.
Let's see. Now,
And finally, what we end up with is
The big reveal.
Haha!
There we go. Oops. Let's jumped the wires. Let's not have them in the way. Ta-da-da-da! Great. So
Pretty simple.
pretty simple.
And what's really cool about this is, as you can see, it's really easy to fold this guy down, you know, in the field. But of course, you don't want that happening while you're flying. So when you put this canopy over it, what happens is there's grooves in this canopy that will go ahead and snap down on these bars. There we go. And now it's not going anywhere. And the same thing for when you want to fold it down now. Just pop the canopy. It's like a Batmobile. And then fold it down.
You can.
Whoops. And then you can store it the same way. It's got the snaps over here and over there. And so now you're good to just go ahead and strap it to your backpack and go hiking.
So put it as a.
Right, it does plus 10 damage, in fact, and increases your stamina by 0.3%.
So it's a perfect sword.
Okay, well, let's go LARPing, and until then, we should probably screw on maybe the landing gear and some of the other stuff.
Some more of the optional stuff.
Right. I don't put the entire landing gear on mine, but I'm also not carrying massive payload most of the time, but it is important to you'll see here you've got these claws, and these are going to snap into our next carbon fiber spars, which our landing gear connects to. But furthermore, what's going to happen eventually is we'll want to place our battery on the bottom here, and we'll want to keep the center of gravity with it because our battery is one of our most heavy objects to strap on. And you don't really want it wobbling or anything.
Yeah, or you don't want to land on the battery itself.
You do not, because as we said before, LiPos don't like to be punctured.
No.
Yeah. So why don't you go ahead and assemble this, and I will grab the other pieces. And these are the spars I was talking about. They're just carbon fiber tubes, and they've got nice little plastic end caps where we can go ahead and snap that on and make it a little prettier.
Okay, and here we have a plate that we will mount the plastic parts onto. This is what I will put together. Teamwork.
Yeah, it's like Lego. Can I get a 2x2 flat? And so the longer carbon fiber spars are actually going to be our landing gear. And so the way that these guys work is we pop on these little rubber spacers. These are pretty cool because it's going to cushion our landing, and you'll notice that we have them both in yellow as well as in black. And the reason for that is, since we are going to have to choose a direction that is forward, we'll want to go ahead and be able to give ourselves a visual clue when this is in the air and decide the yellow is the front, or the yellow is the back, and something like that. So we'll do that to both an arm, or the arms, and the landing gear. And then as far as our legs, the way that these work is that we unscrew these, and then this slides through right there. And what will happen is we can fold the landing gear down like this, and then when we want to use it, we can just fold it up, and this will actually hold the smaller spar, and the spar right here will snap into these little claws and then hold it in place. So we'll go ahead and set that in.
Again, wiggle, wiggle.
Wiggle, wiggle.
There we go. And screw it in. Nice and tight.
Same thing on the other side.
There we go. Nice and tight.
All right. And now we send this spar through.
Yeah, like that.
Just like that, yep.
And we can
just go ahead and snap these in, and that holds it into place. And now we have one set of landing gear ready to go. So let's go ahead and do the same thing on the other side.
Just a little bit tilted.
Yeah, it'll be fine once we get these spars on. They'll stay. Oh, it's actually rotated?
Yeah.
Well, that's interesting. I think it'll still hold. Let's see what happens. It's going to cause for an interesting posture.
Yeah.
Okay. Here's how we fix that. Let's take this off. Let's loosen this screw. And then we can rotate it. And then, and it's just a, looks like a 1.5.
Yeah, a good set of screwdrivers is always useful.
It is a 1.5, right? I can't see with the lights in front of us like that. Can you see that? There we go. Okay.
Okay.
So loosen this. And then let's use this as a guide to allow us to straighten it, because
yeah, there we go.
Okay.
No, wait. Now it's nice and straight.
Okay.
There you go.
Nice and tightened down.
Now when we remove that, it should be straight. Oh, we can leave it.
Yeah, you can actually leave it for now. And let's go ahead and do that again. It's really satisfying, that click.
Yeah, don't be afraid. It is very, very stiff. So
All right,
there's.
let's go ahead and lift these guys up. And then finally, we take our little rubber guys here in the end, and we just arbitrarily decide that this is the front. And I'll go ahead and put one at the end there, and one here. Okay. Then if you want to get the black ones on that side.
One, and two, and then another black one, please. And one. Bloop.
There
And
you go.
nice. And done. All right, now we can turn it around
Okay.
and see how it stands. Now it's standing
Standing
and tall.
tall and proud.
proud. Yeah, you want to adjust the orientation of this.
Right, you can spend a little while tweaking, but we're just going to go ahead and move on with these, because we need to screw our top down.
Yeah, it is screwed down by the joints here, but
Yeah.
we want to make it more stable.
Yeah, and it's actually really nice the way that this top section actually just goes ahead and sits on these grooves that are already cut out for it. So it's really well made in that sense, and it would probably stay on no problem here, but there's no reason not to go ahead and over-engineer, as it were. And if I recall, I believe it's these. There's 1, 2,
The shorter ones.
3, 4, 5, 6, 7. So there are 8. So I believe there are 8 of these.
I have one.
Yeah.
Is that wrong? 2?
No, we're good. We're good. Keep going. Let's see. Just making sure we have 4 of these. And so picking up, Paul, not on us mumbling about how we have spare screws. In fact, it's very much like building any computer. If you don't have a couple of screws extra left over, you must have done it wrong. Although no one is bleeding, so this is good.
This is a very good thing. If I find this
Knuckle
is
check.
a little bit
Yeah, just keep wiggling.
wiggling. There we go. Plastic takes, and you feel the
Grippiness.
grippiness.
I think these need to be flusher.
Yeah. All right. I don't know. This is like, oh, there's still some wiggle room. Oh, they didn't completely snap in yet.
Yeah, here, I'll hold it down, you tighten it.
Because you don't know the friction. Yeah, there we go. Okay.
Yep. You don't want something to build up and have them wiggle loose in flight.
Yeah, that's right. There we go, one.
In fact, pro tip, Loctite is your friend.
Yeah. Blue and red. There we go.
All right.
Are we good?
Yeah, I believe
All
so.
flush? Nice?
Everything looks good.
Awesome.
All right.
See if these need some more loving.
Mm-hmm. Another thing is that we flip this over, that piece that you built.
All right. I didn't
Right, and so
take it down yet.
you may notice, oh, you haven't screwed that down?
No.
Okay, I'll let you screw that down.
I didn't have the...
Ah,
Okay. Don't stab yourself in the finger. There we go.
all right. And then we may also notice, lastly, this piece, you may be wondering, what is that for? The idea is, they're really nice that they fold down, but there's nothing really keeping them there but a little bit of tension. And so what you do is you take this guy here, and you go ahead and snap him in at the bottom. So if you wanted to go ahead and tug on that and snap that guy in. And this will serve as our battery tray.
And then
You push him down while you lift up that leg, and then snap him in place.
now it is nice and stable.
And now we can slide our battery in here, and it will be protected, and as well as making sure that our legs aren't going anywhere. Look at that.
Yeah, but you can also mount the plate on the other side depending on the size of your
Equipment, sure.
equipment, and you can screw stuff to it.
All right,
that
this
you
is
want and so on and
perfect
so
for mounting a GoPro. So
Yeah.
that's good stuff as well. All right, so that right there is the frame. And as we've done, we've left the wiring on the outside, so it's not as pretty. What we're going to do is zip tie these down and then go ahead and tie it into our power distribution, which is literally what's called a Dean's connector. Interesting thing about these and most connectors is that the part with the exposed metal outside is going to be what receives the energy, whereas our female connectors are going to be what sends the energy. You don't want it the other way around, because then there's the chance
Otherwise you have it exposed and you could short it.
Yes, and that's no good. Lipos also don't like being shorted.
Yeah, a lot of rules.
Yes. So let's go ahead and do that. Let's zip tie these down, and let's kind of test fit our servo control leads, which are the black, red, and white wires coming from our motors. That's negative, positive, and signal, as in how fast do we want you to spin and other stuff.
Yeah, it's command, yes.
Yes. I'm going to grab some zip ties. Do you want to see about those, or should we do that last?
This is for the battery.
All right. Now on other frames where we don't have a choice of, say, sending our wires through the insides of beautiful little carbon fiber spars and stuff, what you can do and what I've seen done is actually use some of this wire loom material, which is really nice because you can just send your stuff through here. It really is, it's fun stuff to work with. Have you used this?
Yes, this
Yeah,
is
it's such great material.
Pulls off. It's similar material to the finger traps.
Right.
So it expands, and you can put stuff in there, and it expands. So
Yeah, this is good stuff.
and it pulls together when you. All right. So these are the zip ties. Let's see how we want this. So let's align the wires nice and tidy, so that they are close to the boom, and it's pre-zip. Okay. You don't want to pinch it.
Right. Just something a little snug. We should still be able to slide it around until we get everything just right. So we'll go ahead and do that on all four of these.
Yeah. Or we do this. Okay. You might want to twist the power wires together eventually.
So why do you twist the power wires together?
So that they are nice and close together, so when they oppose each other in the electric field they create.
Oh, well, we've been talking about that a lot on
So-
Hak5 as far as like electromagnetic fields and radiation, basically radio. So you're saying give it something like that,
A twist.
a nice little twist. Okay, so it's like Cat5.
Yeah, exactly. And this way you will decrease the probability of creating interfering magnetic fields.
Okay, I'll buy it.
It is easier when it is not inside the plug. So if you want to make it nice and tidy, the twist, you can also remove the tabs from the...
I'm finding you just do this. It kinks up and then you let go. And what you end up with is something half decent.
Yeah, nice.
Well, at least it was on my other ones.
Yeah, depends. They are not all exactly the same length.
I see.
It's manufacturing. Right.
Now, this nice little power distribution cable actually takes a Dean's connector that goes to our battery and gives us 6 of these JST cables. And again, these are just for power. And this is the same cable that is on our ESC, which will thus power our motor. And what's really nice is we can just hook all of these up and slip this right down through the hole all the way down to our battery compartment.
Yeah, we can also, there are many ways of doing it. We can also have it come out at the side here, for example. Then you have it also out of the way. That's nice. And it is not all bundled up under the autopilot.
Right. So why don't we want the main power cables underneath the autopilot?
In our case, in Lisa M case, you have the magnetometer directly here. So it is a compass, but it measures magnetic fields. So if you run current through a wire, you're creating a magnetic fields. So depending on the throttle you are setting on your motors, your magnetic field will change. And if you have the wires run directly under the board, it will be not very good. Your north will move, depending on the throttle. So that's why some other autopilots bundle the magnetometer with the GPS, and it's standing on a tall boom on an antenna. You can do that. You can wire it up as an external sensor. But in our case, we have it directly on the board for now.
So for us, we just need to make sure that we keep our power away from that. And in this case, this is actually why it's much easier, in fact, keeping our power or all of our cabling external from our booms, is we can just route everything through the EPS conduit and into the main deflector array.
Exactly. So let's just hook it up. We can tidy it up when we actually know where things go.
Okay.
Exactly. So let's do that here. Let's pull it. We can also route it inside, but for now it's like you get the.
In fact, once we put the canopy on it, you're not going to see any of that.
No, you won't gonna see it. If you want, you can also run it inside. It's like I just like to have.
See, I'm
the
an
wires
out of
away.
sight, out of mind kind of person.
Right.
So as far as I'm concerned, it's gone.
It's gone.
Yeah.
For the zip ties, when we are happy now that they are.
Yeah, I am. So I'm going to tighten them down just a bit. I don't want to squeeze the cable, really.
Yeah.
I'm going to put kinks in it.
It's good enough. Now we can nip off the excess. Don't nip off it completely to the knob. Then you have a chance of tightening them later.
I see. Oh, what direction is the board going to face? Because all of our servos need to be on one side.
It doesn't matter.
Oh, okay.
So we can set in the airframe file which direction the autopilot is pointing. It's like we can mount it upside down, 45, 35, whatever, as long as you know what it is. You can change it in the airframe file. This is like, it's all adjustable. So I think this is a nice orientation because this is offset. So if you see, the holes are drilled for the autopilot offset to one side so that we have something to drill into.
Right.
So I think this direction is nice. We should choose this. Come on. There we go. and we go down. But we will also add some more spacing.
Some
here.
nuts, some spacers?
Yeah, some spacers.
Okay.
And now we can plug in, but this is the basic idea.
Awesome. This is fantastic. So we have our flight controller mounted, we have our motors and our ESCs and everything wired, and it's really just a matter of now plugging it in and programming it for this setup.
Yes, and then we can start testing the motors and
do our safety checks and then have our first maiden flight.
Yeah.
I'm super excited, so stay tuned, and of course we'll take a quick break. Well, that just about wraps up this week's episode of Hak5, and as always, we'd like to remind you, Shannon, why don't you remind him all the stuff? Don't feel like doing this show right
Get
now.
up here.
No.
Get
No.
up. Get up
No.
here right now.
No.
Get.
Tell them about hak5.org/follow. What do you find there?
You find social network stuff,
There you go.
including our Twitter accounts, Google Pluses, Facebooks, and events.
Oh, what's happening July 9th?
Tour camp?
Yeah, it's in Nia Bay, Washington, and you guys
Maybe.
have to come out. It is going to be the most epic hacker camp ever. So tourcamp.org. I can't speak highly enough about it. It's nearly a geek spiritual experience, open for all skill levels, and it's like Woodstock. You can't miss it.
Also, you should probably know that I am celebrating because I'm getting married this weekend.
So last chance to propose, Shannon at hak5.org. You can also stalk her at Snubs on Twitter.
No!
What else? I'm sorry. And then if you'd like
And
to
then
support
also-
us directly, there's the Hack Shop.
You want to go to the hack
It's
shop
at
and buy your own RTL dongle.
hakshop.com. You can get your dongles.
AKA
on.
shop.
Yes.
No, we have the HackerF.
Well, we have the HackerF, and I'm working with that next week with a little bit of Kali Linux.
Are
Get
you?
some GSM on. It should be
Did
a
you
lot of
fix
fun.
it yet?
Yeah, kind of. I got some dependencies that I need to. Yeah.
Also, we have, is that it? Did we do a brunch already? this
Yeah.
week?
We'll announce the next one soon.
Okay, cool.
It was an awesome brunch. We can only imagine it. It's not done yet.
It was great.
Yes.
It was fun times. My name's Shannon Morse.
I'm Darren Kitchen.
I'm gonna go
I
drink.
give up.
Bye. Trust your technolist.
That's what we say.